In today's video, we will continue looking at methods of examining and summarizing numerical variables or data. This discussion will focus on looking at numerical data from a one-dimensional point of view with an emphasis on finding the so-called five-number summary. Recall that previously we looked at the following two key summary values for a two-dimensional view of numerical data. First, we looked at the measure of center, known as the weighted mean or average, and secondly, we looked at the measure of variability or spread, known as the standard deviation. Also, we looked at the following two graphical representations associated with a 2D view of numerical data. First, we looked at dot plots, and then secondly, we looked at histograms. Throughout our discussion of the two-dimensional view of data, we used the lone 50 dataset from the textbook, focusing on the interest rate variable. We will continue to use the lone 50 interest rate variable in our discussion of a one-dimensional view of numerical data. Let's begin by turning our attention to what is known as the five-number summary. When looking at a one-dimensional view of data, we must begin by ordering the variable values from smallest, that is the minimum, to the largest, that is the maximum data value. Note that below I've numerically ordered the interest rate variable values rounded to the nearest whole number. The position numbers are shown above each of the variable values, so note that the minimum interest value is 5% at the far left under the first position, and at the far right under the 50th position, the data value corresponds to 26%. Notice that in the linear one-dimensional view of the data, I've split the data into two equally sized halves, so the left 25 values and the right 25 values from 26 to 50 are shown on the right. The measure of center for a one-dimensional view of data is called the median, denoted as x with a tilde over it. It's the variable value that would be in the middle. So in our diagram, in this case because we have an even number of data values, the median is the average of the two data values around the middle or the center. So in other words, in this case, the 25th data value and the 26th data values are averaged. And so since 10 plus 10 is equal to 20 divided by 2 is 10, our median value is also 10%. If there were an odd number of data values, then the median would be the value in the middle. Now, notice that I have taken the linear one-dimensional view of the data where it's all ordered again, and I've split the data into four equal-sized pieces or quarters. So there's 12 data values to the left, another 12 data values here from 8 to 10%, another 12, and another 12, and then there are two that are in the middle of the third and fourth quarters, and the first and the second quarters. And of course, we know that in the middle, the median value is blank. There's nothing there. The data values that are at the quarter boundaries are known as quartiles, of which there are two of interest. First, there's quartile 1, or the first quartile, which I have shown on the left with an arrow underneath it. That corresponds in this case to the data value of 8%. The other quartile of interest is the third quartile, or quartile 3, and that's shown at the right with a blue arrow underneath it. And we can see it corresponds to the 38th data value in this case, and it has a value of 14%. Notice that the second quartile, or Q2, already has a special name. We call that the median. And of course, the fourth quartile, or Q4, is the maximum. Collectively, the five numbers that we've just discussed, that is the minimum, Q1, the median, Q3, and the maximum for the one-dimensional view of a numerical variable's values are known as the five-number summary. There are two corresponding numerical measures of variability or spread for a one-dimensional view of data. First is the range, which is equal to the maximum minus the minimum data values. And then there is also the interquartile range, or IQR, which is equal to the third quartile minus the first quartile. Note that the interquartile range is analogous to the standard deviation.